The current unit we're in is all about functions. So one thing we need to know is how to determine something as a function. I know you've looked at this before. A function is basically any kind of relationship where every single independent variable gets one and only one dependent variable. Remember, the independent variable is going to be in your typical XY situation, the X. So notice I pointed out here that one way of thinking that is every X gets exactly one Y. So what does that mean? That means it's going to pass a vertical line test. So like I said, I know you've seen this before. We've talked about domain before. Remember, domain is all your possible independent variables. This is also often called your input values. The range is all your possible dependent variables, which again is also often called the output values. So if I'm looking at determining if something's a function, all I need to do is really just plot the points. And I don't have to do a real great diagram of it. I would go 1, 6, 2, 8, 3, 8, 4, 9. So I can see right away that yes, I would pass the vertical line test. So is this a function? You bet it is. If I do the same thing for my next set of data points, I have 1, 2, I have 3, 4, I have 4, 5, and I have 3, 6. So notice this one does not, because 3, 4, and 3, 6 are going to be above one another vertically. So this is no, it does not pass the vertical line test. What we really want to focus on, though, is not just that I can do it with points, but what about if I'm talking about an application type problem? What if I'm talking about the input, remember, which would be my domain values, are student ID numbers. The output is the student's grade. Well, if you think about your class, every single person, so if it says the input is student IDs, I'm going to put my student IDs on the x-axis, STIDs. I'm going to put that on the x-axis, and then the output is the grade. So the grade I'm going to put on the y-axis. I'll just put G. So every single person in this class is going to have a different student ID number. No one gets the same student ID number. You guys might have the same grade, but notice that it's okay if you have the same grade because that's just going to be at the same horizontal line. But no one's on the same vertical line because every single person, again, every single X value is going to get only one Y value. You're not going to have two different grades for one student. So it looks like, yes, this is a function. If I look at Gilpin's heights and corresponding shoe size, it sounds like I'm talking about their heights being the independent variable and their shoe size being the dependent variable. Well, if I started labeling everyone's height, we probably have more than one person who are, for example, say 5'7". That's a very common female height. So if I said, everyone who's 5'7", tell me your shoe size, maybe the first person who's 5'7" says, my shoe size is 7.5. And then the next person says, my shoe size is 8. And then the next person says, mine is 7.5 too. Mine is 8.5. So all of a sudden, notice I start breaking this vertical line test. So I'm going to go ahead and say no, that the Gilpin students' heights and corresponding shoe sizes would not be a function. It can be time consuming to draw a graph. Oftentimes we want to do things in our head, but notice that I'm not doing a real nice graph. I'm not getting graph paper out. I'm not labeling all my points. I'm just giving myself a visual to help me interpret this information a little bit better and be a little bit more successful when I'm interpreting it. The other thing we need to talk about in this video is function notation. So function notation is somewhere that students tend to struggle. Finding f of 2, you guys are f negative 2. You've done this before. We did this last year. No problem. What does this tell me to do? It tells me to go to my function, and every time I see a variable, I'm going to plug negative 2 in that place. So here's my function. I'm using it for A through D. All right, so I'm plugging negative 2 in. So right away I hit an x squared. So x squared becomes negative 2 squared. Minus 2 drops down. Now I hit an x. X becomes negative 2. I drop the plus 7 down. From here I just simplify. Negative 2 squared is 4. Minus 2 times minus 2 is plus 4. Plus 7 gives me 15. No problem, correct? We've done that before. What about if it's not just a number? What if it's a number and a variable? A little bit more tricky, but not really. See, it works the exact same way. This tells me still to go to my function. Every time I see a variable, put 3x in that variable's place. All right, got it. I already know where my function is. It's right here. So I'm going to put 3x in for x and then I'll square that. My minus 2 drops down again. In place of this x here, I put 3x. My plus 7 drops down again. Simplifying this, I get 9x squared minus 6x plus 7. Because I don't have any like terms, that's the best I can do, and that's my final answer on this one. So notice, just because I'm evaluating doesn't mean I'm going to get a nice solid answer, or numerical answer. I may get an expression. Getting a little bit more difficult. What if I have f of b minus 4? Now I no longer have a monomial. Now I have this binomial. All right, no problem. Works the same way. I go to my function. I put b minus 4 in for every variable. So instead of x squared, I have b minus 4 squared minus 2 times b minus 4 plus 7. All right, I can simplify this. I know b squared minus 4. Maybe I have to do a little bit of scratch work, so I'm going to move my paper over so I can do some scratch work and do b minus 4 times b minus 4. B times b is b squared. B times minus 4 is minus 4b. Minus 4 times b is minus 4b. Minus 4 times minus 4 is plus 16. And I know my middle terms combine. Awesome. Notice I did not distribute the square into a binomial. Write it twice in FOIL or use a formula. So I now have b squared minus 8b minus 16. That is from this piece only. Now I'm going to distribute my minus 2, giving me minus 2b plus 8 plus 7. Combine like terms, I get b squared minus 8b, and my 16 there kind of looks like a b, I apologize. Maybe I should have picked a different letter. Minus 8b and minus 2b is minus 10b. Minus 16 plus 8 is minus 8, plus 7 is minus 1. So I get b squared minus 10b minus 1. So again, trickier, more work, more to simplify, but exact same process. I go to my function, and every time I see a variable, I put whatever I'm taking, whatever in place of my x, whatever I'm trying to evaluate for, in for in for the variable. So now let's look at part D. Still a little bit trickier yet. So part D, I have to find what f of x plus 3 is, and then I have to subtract the entire f of x function. Okay, no problem. I'll take it in steps. So first thing I'm going to do is I'm going to figure out what is f of x plus 3. Go to my function. Every time I see a variable, put x plus 3 in its spot. Very similar to letter C. So I have x plus 3 squared minus 2 times x plus 3 plus 7. Okay, that is all of this is this part of it. I have to simplify it, but it's that part of it. From there, I'm then going to subtract my entire f of x. Well, what is f of x? Well, f of x is x squared minus 2x plus 7. So I'm going to subtract the entire x squared minus 2x plus 7. Notice if I did not put parentheses or I used brackets, you could use parentheses. Doesn't matter. I just didn't want to use parentheses because I already had parentheses in here, and it sometimes gets to be a little much. Notice that if without those brackets, I would be subtracting the first term only, and this tells me to subtract the entire function. From here, I clean it up. So x plus 3 times x plus 3 is x squared plus 6x plus 9. If you don't believe me, do the FOIL. Distributing my minus 2, minus 2x, minus 6 plus 7. Distributing this minus all the way through, minus x squared plus 2x minus 7. And now I'm going to combine like terms. So I can say, hey, guess what? X squared and minus x squared, they combine to be 0. Minus 2x and plus 2x combine to be 0. Positive 7 and negative 7 combine to be 0. So, last thing, then 9 and minus 6 are going to be 3. So it looks like I'm left with 6x plus 3 for my final answer. Looking at one final example, this is by far the hardest. I'm sorry because I know this video is a little bit longer than most. A lot of information in here. Please stick in all the way through this example because this is the hardest one by far and the most important one. So all A through D are getting me ready for letter E. Letter E says find f of x plus, triangle x is read as change of x, minus f of x all over change of x. I'm given a new f of x function, x squared minus 2x plus 3. And this is just telling me that, hey, go ahead and use that function. It's okay. We know that's not 0. That's all that piece of information is for. If you don't like change of x, rewrite it as a different variable. I still see students in my calculus class go, wait a second, I really don't like that. And I say, so make it a y. Make it something you like. Just remember in your final answer to go back and put it back as a change of x. So here we go. Very similar to part D on the top. So f of x plus change of x is go to my function. Okay, I'm there. Every time I see a variable, x plus change of x is going to get put in that place. So I have x plus change of x squared minus 2 times x plus change of x plus 3. That is my first part only. That was this. Now I'm going to subtract the entire f of x function. I have to put it in parentheses to show I'm taking the entire function off. X squared minus 2x plus 3. That's easy. I'm told what f of x is right here. That is all divided by change of x. I'm going to simplify. X plus change of x squared. I FOIL it and I get x squared plus 2x change of x plus change of x squared. I distribute my minus 2. Minus 2x minus 2 change of x. My plus 3 drops down. Now I distribute this minus sign. Minus x squared plus 2x minus 3. This is still all over change of x. Because I'm out of room, I'm going to kind of write it as a slash instead of under. I combine like terms. Guess what? My like terms are very similar to the last one where I'm going to have a lot of stuff drop out. So I'm left with 2x change of x plus change of x squared minus 2 change of x all over change of x. Hey, that's really nice because on top I have a common factor of change of x. So I'm going to factor that out. And I get change of x times 2x plus change of x minus 2 all over change of x. I factored out of a change of x. Why did I do that? Because now I can cancel my change of x out now that it's multiply. And here is my final answer. I don't have room to rewrite it. I would normally rewrite it. 2x plus change of x minus 2.